This deck of cards was compiled to help you get through the MCAT passage, the role of the bicarbonate buffer system in regulating blood pH. All right, so let's get to it. A buffer is an aqueous solution that resists changes in blank when acids or bases are added to it. So fill in the blank. It resists changes in pH. A buffer solution is typically composed of a strong or weak acid and its conjugate base. So what's the best fit, strong or weak? The answer is a weak acid and its conjugate base. There are three major buffer systems that are responsible for regulating blood pH. The B blank buffer system, the P blank buffer system, and the plasma protein buffer system. So fill in the blanks. The first blank is the bicarbonate buffer system, and the second blank is the phosphate buffer system. Two very popular polyatomic ions in the human body. The B blank buffer system is the only bodily pH regulatory mechanism coupled to the respiratory system. So what is that B blank? That would be the bicarbonate buffer system. The most commonly talked about buffer system in biochemistry as it relates to the human body. What is the molecular formula for carbonic acid? The molecular formula for carbonic acid. Well, you can already guess that there's going to be some protons in there. The molecular formula is H2CO3, and it's an aqueous phase, an aqueous liquid phase. Carbonic acid is a strong or weak acid. So is carbonic acid a strong or weak acid? And as you probably guessed, it's a weak acid. Carbonic acid is formed when carbon dioxide combines with water in a reaction catalyzed by the enzyme C blank A blank. So what is the name of that enzyme? That would be carbonic anhydrase. Carbonic anhydrase. In solution, carbonic acid is present in equilibrium with the blank ion via a proton transfer reaction. So what is the ion that goes in the blank? That would be the bicarbonate ion. So again, that's the bicarbonate ion. Blank blank principle states that when stress is applied to a system in equilibrium, the reaction will shift in a direction that will reduce stress. So the reaction will shift in a direction that will reduce stress. So what principle states this? That would be Le Chatelier's principle. A process that acidifies blood is neutralized by B blank E ions, thus minimizing the change in pH. So what ion is this? That would be the bicarbonate ion. So that's the bicarbonate ion. A process that alkalizes blood, and when I say alkalizes, I mean raises the pH, is neutralized by the equilibrium concentration of C blank acid. So what acid goes in the blank? Carbonic acid. That would be carbonic acid. Write the chemical equation describing the equilibrium between carbonic acid and bicarbonate. So this is one of the most famous biochemistry chemical reactions that's discussed in science as it relates to the human body. So first you start out with gaseous CO2 and liquid phase water. That's going to equilibrate between carbonic acid, and of course that's in the aqueous liquid phase, and that's going to equilibrate between the bicarbonate ion, of course in aqueous solution, and protons in aqueous solution. All right, so just take this in, and it would be good to memorize it. A blank S acid is a substance that when placed in water increases the hydrogen ion concentration. An A blank S acid. That would be, that's an Arrhenius acid, an Arrhenius acid. A B blank D dash L blank RY acid is a substance that donates a proton. So a B blank D dash L blank RY acid. What acid is this? What type of acid? That would be the Bronsted Lowry definition for an acid. Okay, this definition is based upon proton donation and proton acceptance. A L blank acid is a substance that serves as an electron pair acceptor. A L blank acid. That would be a Lewis acid. So this is a definition of a Lewis acid. And the way I like to keep this straight, so I don't get it confused with a Bronsted Lowry acid, is Lewis electricity. I'm not sure if that's some type of mnemonic, but electricity, not electricity, revolves around electron flow. So Le to me looks like electric, which would be extracted from electric. B blank R regions are the flat segments of titration curves. Because these are the regions where the pH changes very little when the titrant is added to the solution. So as it relates to titration, what are the B blank R regions? That would be the buffer region, or regions if there's several in a single titration curve. The range of a buffer region is blank to blank. So what is the range of a buffer region? That would be pKa minus 1 to pKa plus 1. All right? The H blank dash E blank E point is the point where exactly 1/2 of the acid has been converted to its conjugate base. This represents the center point of the plateau in the titration curve. So it is the H blank dash E blank E point. That would be the half equivalence point. The half equivalence point. All right. The E blank E point is the point in the titration curve when all of the acid has been neutralized by the strong base. The conjugate base of a weak acid will predominate at this point. And that would be the equivalence point. At the equivalence point, the conjugate base of the weak acid predominates. The Henderson-hasselbach equation is used to calculate the pH of a blank solution. So the Henderson-hasselbach equation is used to calculate the pH of what type of solution? That would be a buffer solution. Okay. The Henderson-hasselbach equation, write it out. So write the Henderson-hasselbach equation. Okay. So this is the Henderson-hasselbach equation. It's a very famous equation in organic chemistry. So pH is equivalent to the pKa plus the log base 10, this isn't natural log, of the concentration of A negative, that's the conjugate base, over the concentration of conjugate acid. And so this equation is used to describe the equivalence point, which will have a value that's higher than the pKa. And if you look in the top, so if you look in the top, the numerator of this ratio, you have the concentration of conjugate base. So at the equivalence point, this predominates, and then you're going to get a larger log, and then you're going to get an increase in the overall value of the pH. Okay, but when the concentration of the conjugate base is equal to the concentration of the conjugate acid, you're going to get 1. And everyone knows, or you should know, that the log of 1 is 0. Therefore, at this special place, pH is going to be equivalent to the pKa. So the blank is equal to the pH at the half equivalence point. The point where exactly 1/2 of the acid has been converted to its conjugate base. This I just discussed with you in the previous set of cards. So what goes in this blank? And at this point, the pKa is equal to the pH. And again, when pKa is equal to pH, exactly 1/2 of the concentration of conjugate acid has been converted to its conjugate base.